It's important that you tried the warm-up for today. It asked you to draw a triangle that had a 40 and a 50-degree angle, and then it wanted you to do some precise measurements on the sides. Did we all get that the third angle would have to be 90 degrees? Because the 40 and the 50 already added up to 90, so that other angle would have to be 90, so that we all drew right triangles. But on number 2, when we measured the 3 sides very precisely, I bet we didn't get the same answers because we weren't told how long to make the sides, we just made them. And so we probably don't have the same answer to number 2. But the interesting part comes when we look at number 3. Number 3 said to write the ratio of the longest side to the shortest side. In my case, it was the 6.3 to 4, which reduced to 63 to 40. And I actually divided that out and got 1.575 to 1. And the point of this warm-up is if we all measured precisely, that ratio should be pretty close to 1.556 if we were perfect. For all of us, no matter how long our side lengths were, we should have all gotten that same ratio for the sides. What does this have to do with similar triangles? Well, let me take you back to that definition. Congruent angles, proportional sides. So remember when we had to list out all the congruent angles and all the proportional sides? Well, on our warm-up, we all should have had congruent angles, right? We really had no choice. Once we were given the 40 and the 50, that third angle had to be 90 degrees. But we weren't told anything about how to make the sides. But the crazy thing is, if we all did these correctly, that ratio came out the same for all of us. So does that mean we don't need to check all the sides being proportional as long as we know that the angles are congruent? Could we get away with just checking congruent angles and forgetting about proportional sides? Well, the answer is no. Do you remember this example about the rectangles? Those angles were all congruent, but the sides weren't proportional. So in that case, I couldn't just check the angles, I had to check the proportional sides. But if you read ahead a little bit, there is a shortcut, but it only works for triangles. That explains why it wouldn't have worked for that rectangle one. It is called the Angle Similarity Postulate, AA. It says that if 2 angles of one triangle are congruent to 2 angles of another triangle, then the 2 triangles are similar. That's a big deal for us, you guys. If we can just find 2 sets of congruent angles, we don't have to mess with any of the sides to check to see if they're proportional, because they automatically will come out proportional. So if you can find angle congruent, then your triangles are similar. Only works for triangles though. So if you asked me yesterday if I were checking to see if these triangles were similar, I would say not enough information for all 3 of them because I'm not given any side lengths. But now I have this new postulate, and that means that I only have to check to see if I can find 2 congruent angles. In this first one, I see angle R is congruent to angle F. The 71 and the 30, I wonder if I could find angle Q down here. Angle Q would just be whatever 180 minus those other 2 angles is. Hey, that gives me 31 degrees. So if that's a 31 degree angle, I can say that angle Q is congruent to angle G. And I could go use the same technique to figure out angle H, but I don't need to. There's that third angles theorem from back in the day, but also it's called the AA Similarity Postulate because if you have 2 sets of congruent angles, you automatically have a third, so you don't even need to bother checking. Now that I know I have 2 pairs of congruent angles, I know that the sides are proportional because that new postulate tells me, yes, those triangles are similar. And since they're similar, I can write a similarity statement. I'm just making sure that my angle R and my angle F, my angle Q and my angle G are in corresponding positions. And there's my similarity statement. The second example could be easier if we drew out the separate triangles. Depends on how you look at it. Well, first of all, I know that that angle Q and that angle T are congruent. They're both 49 degrees. But that wouldn't be enough, would it? One set of congruent angles? Do we have one more set that we know is congruent? If we knew these were parallel, then I could say that these were congruent because they are corresponding angles. But they didn't tell me those were parallel. So how about that other angle up top? That's the ticket. Angle R would have to be congruent to angle R by the reflexive property. So no need to check angle V and angle S. That's enough information for me to say that yes, those triangles are similar. And I can write a similarity statement. On this last example, I can see that angle L is marked congruent to angle ONP. I would just need to find one more set of congruent angles. Great news, I'm seeing parallel lines that are marked right here. What could we use for the transversal? I suppose we could use this as the transversal, but that's not going to really give me angles that are inside the triangle. So what if we choose this as the transversal instead? Can you see how then angle P right here and angle N right here would be corresponding angles? They're in the same position, the upper left corner. So then I know that angle LNM is congruent to angle P. And that's all it takes. What a great shortcut. Because they're triangles, I only have to find two sets of congruent angles, and I can say that yes, these triangles are similar, and I can write a similarity statement. And that is the angle-angle similarity postulate.